All right, welcome. Today, we're going to bridge a gap between two totally different data worlds. On one side, you've got the super clean, orderly universe of databases, and on the other, the flexible, kind of free-form world of web documents. Let's jump in.
So here's the fundamental problem we're going to tackle. Your database speaks in tables, but the web speaks in documents. How on earth do you translate between the two? Back in the early days of the internet, this wasn't just a minor issue. People were calling it a technology train wreck. You literally had these two powerful, but completely different ways of handling information just hurtling towards each other. The big question was, how do you make them talk without everything just blowing up?
So what exactly makes these two worlds so different? Well, look at traditional database processing. It's all about structured data. Think tables, rows, and a really rigid schema where everything has a very specific place. It's neat, it's organized, but then you have document processing, which is the language of the web. This is semi-structured. It's all about tags and hierarchies, and it has a way more flexible schema. It's designed to describe what the content is, not just jam it into a neat little box. And getting these two to communicate, well, that was the challenge.
Okay, but hold on. Why couldn't developers just, build their own translators? Why did we need a whole new standard for this?
And that's a fantastic question, because it gets right to the heart of the matter. Imagine this. What if every time you wanted to send an email to someone using a different email provider, you had to build a custom translation program? It would be absolute chaos. Well, that's basically what data exchange was like. Every system, every application, every organization had its own proprietary way of doing things. The real problem was that we needed a universal standard, a common language that any system could speak and understand right out of the box.
And that's where our hero, so to speak, enters the story. To solve this huge data exchange problem, the tech world came up with a pretty brilliant solution: XML. XML stands for Extensible Markup Language, and it was designed from the ground up to be that universal translator. Now, the key thing to get here is that this wasn't about making web pages look pretty. That was HTML's job. Nope. XML was created to describe the data itself. It gave us a standard, but also a super customizable way to describe the structure and the content of pretty much any document you can think of.
So, what made XML the perfect tool for the job? Well, first, it created a clean separation between the data structure and how it was actually displayed. That was huge. Second, its tags were all about meaning. See, an HTML tag like B just tells a browser, make this text bold. But an XML tag like price tells any system, hey, this number right here, this is the price. The tags describe the data, not how it looks. Plus, they weren't ambiguous, and because it was a real standard, everyone could trust it.
Okay, this all sounds great in theory, but how does this actually work with a real database? How do you actually get that clean, structured data out of a table and into one of these fancy XML documents?
Let's start with something we all recognize. Here's a simple department table from a relational database. We've got our columns, we've got our rows. It's the exact kind of structured data we've been talking about. Now, let's see how we work some magic on this.
And this is the amazing part. The process became incredibly simple. All the big database players like Microsoft SQL Server, Oracle, and MySQL, they all built facilities to handle this. With SQL Server, for example, you could write your normal select statement and then just add one powerful little clause at the very end, for XML. That's it.
And voila, here's the result. Instead of a table with rows and columns, the database gives you back this perfectly structured XML document. Each row from our original table is now neatly wrapped in department tags, and each column, like department name, gets its own descriptive tag. The data is identical, but now it's in this self-describing, super portable format that any other application can understand instantly. The translation is complete.
Now, this wasn't just some neat party trick. The ability to seamlessly move data between the database world and the document world had a massive, lasting impact on, well, pretty much the entire tech landscape. If you look at the history of data, it really puts it in perspective. The relational model ruled the 70s and 80s, but then in the 90s, XML comes along and acts as this critical bridge. It connected the structured world of databases to the semi-structured world of the web. And by doing that, it completely set the stage for the next big thing, the NoSQL and big data movement, which is really built on this idea of flexible, document-style data. So why does any of this matter to you today? Because XML's legacy is absolutely everywhere. It was a cornerstone of Microsoft's huge .NET initiative. Its whole concept of self-describing data directly paved the way for modern standards like JSON,
which you see in practically every API today. And maybe most importantly, it established the foundational ideas behind document databases, a huge part of the NoSQL world. The principles XML introduced are still fundamental to how we move data around the internet.
Hey, if you found this deep dive into the history of data useful, do us a quick favor and hit those like and subscribe buttons. And if you know someone who's wrestling with databases or APIs, go ahead and share this explainer with them. It really helps us out.
So we'll leave you with this final thought to chew on. In a world now dominated by lightweight, easy-to-use formats like JSON, what do you think is XML's most important and enduring legacy? Is it the technology itself, or was it the revolutionary idea that our data could be both structured and descriptive, all at the very same time? Thanks for watching.